Okay, welcome to the whatever study with me. This is going to be the even more in-depth Chapter 5 review. We're going to go over all of the homework, all of it this time. And we're also going to make our own formula sheet. And lastly, we are going to go over the lecture problems. That should be real fun. So, quickly, right. Let's see. Q equals CV. And then I'm going to write parallel plate. C equals epsilon 0 A over D. What else do we need to know? E equals Q epsilon 0 A V equals E D I'll write Q equals E epsilon 0 A, and I'll even write the last one. Delta V equals negative integral I initial final E dot ds. Why not? Okay. Goodness me. I'm going to left hand side equals, I can write that better, E dA, and then right hand side equals Q over epsilon 0. Okay. Cylindrical capacitor. We have PP, we have CC. Isn't that funny? And C equals 2 pi epsilon 0 L all over the natural log of B over A. I think this should be change in V, but I'll just write V equals negative initial final of E ds, and I'll do left hand side equals E dA. Well, actually, this is just going to equal 2 pi RL E, and the right hand side equals CV over epsilon 0. Okay. We're going to have a spherical capacitor. C equals 4 pi epsilon 0 AB B minus A. Isolated sphere. So C is going to be the same, 4 pi epsilon 0 AB B minus A. Remove B, 4 pi epsilon 0 capital R. I don't know what the capital R. A equals capital R. So actually, I think it just points to that. I could just say A equals R. Okay. Parallel equals voltage. Equals current Q V. Okay. W equals negative change in U. Change in U equals Q change in V. Okay. With these two noted, we can say that U equals Q squared over 2C equals 1/2 CV squared. Okay. volume equals AD. Energy density U over volume. One half epsilon 0 AV squared over D over AD. That's crazy. Equals, oh my gosh. I don't know how that works out, but it's epsilon 0. It's wild. Okay. 0 equals, well, I don't know if we have anything right now for E0. So is there anything up here for E0? I don't think so. But what we can say is E equals Q minus Q prime over epsilon 0 A, and that K equals E0 over E, and that Q prime equals Q 1 minus 1 over K. Here you go. E0 equals Q over epsilon 0 A over E. Or no. It should be Q over epsilon 0 A. Okay. In parallel, it's going to be C1 plus C2 plus C3. In series, it's going to be 1 over C1 plus 1 over C2 plus 1 over C3 inverse. Last thing I want to say for parallel plate, C0 equals epsilon 0 A over D, and that C equals K epsilon 0 A over D. So got that, got these, got this, got that, got those two. Okay. Now with this, can we do the homework? We need to see more screen. Okay. Oh, I cannot read any of that. That is completely illegible. Oh boy. So we just need to know that capacitance C, can we match that color? Similar to this, but not close enough. Dead on. Okay. C equals, let's make this bigger to match. Oh, just that. How do I? Nope. Oops. Come on, size of 4 pixels. 4 pixels is good enough. How did I get here? Here we go. Okay. Perfect. C equals 26 times 10 to the negative 6 farad, and the potential difference 108. I'm going to say volts. So it's asking us to find charge. Yep. So here, Q equals CV, which is dead easy, dead easy. It's going to be 26 times 10 to the negative 6 times 108, which equals 0.0028. 0.0028. Check. Oops, here we go. Make it vertical. So, two flat metal plates. We have an area, which is 1.2 meters squared. And the capacitance, 1.6 farad. C equals 1.6 F. And it's asking us what must be the separation of the plates. So E equals question mark. Now, two flat metal plates. This looks like parallel plate problem. So we have E. Are we given an E? Given any other numbers? Nope. So we just have area. No charge. Okay. You know, C equals epsilon 0 A over D, which means that D equals epsilon 0 A over C. So this one's going to be 8.85 times 10 to the negative 12th times 1.2 divided by 1.6, which I'm getting equals 6.63 times 10 to the negative 12. And it's less than the size of an atom. Okay. Whoops. Okay. So here we've got, okay. We've got capacitor 1, capacitor 2. This is going to be C3, C4, and then C5. So we're going to have to find C equivalent of 2, 3, C of 2, 3, 4, and then C of 2, 3, 4, 5. Okay, 2 and 3 are in series. So they're going to be added as 1 over 24 plus 1 over 24 inverse. And this is going to be, let's do it right now, since I'll need to anyway. 1 over 24 plus 1. 1 over 24. 24, right? Yeah, 24. And we're going to do this inverse. I did not do it inverse. I did it to the regular verse. So then this just equals 12. Then here, this is going to be 12 plus 24 because they're in parallel. So let's add 24. This is going to equal 36. And these are in series. This is going to be 1 over 36 plus 1 over 24 inverse. Which is 72 divided by 5, which is 14.4. So now we've got all the C equivalents. Here we're going to have capacitor 1, and this is going to be C2, 3, 4, 5, and they're in parallel, which means that the voltage carries over. So this one's going to be 17. Well, we can say Q equals C1 is going to be 24. It's going to be 24 times 17 volts. going to be 408. And then Q here is going to be 14.4 times 17, which is 244.8. Okay, so now we have the charge on both. This is 408. This is going to be times 10 to the negative 6, I believe. 408 e to the negative 6. Yep. And we can keep moving on. Our next capacitors are going to be C5. With C2, 3, 4, and this one's going to be C5. We know that C5 is going to equal, let's see, the charge is going to carry over. So this one's going to be 244.8 equals the C, which is 36 times an unknown voltage. So we're going to divide this, find the voltage here. This is going to be C5 equals 244.8. Voltage carries over. So now, I'll write up here, V, or I don't need to say that. I'll just know it's V. So it's going to be 244.8 divided by a 36. So I'll write it, I take it back, 6.8. The voltage here equals 6.8, and now we've got C2, 3, and C4. And the voltage here is 6.8. So right here, we're going to have Q equals C2, 3 is going to be 12 times 6.8. Q equals 81.6 times 10 to the negative 6. Should be times 10 to the negative 6. Yep. Okay. I love these problems. Smiley face. This one's gonna be the one. Let's see how this goes. And there's no information on that side really. This is the side with all the real stuff we need. We're trying to find the capacitance. How much charge is left on capacitor 1? So capacitor 1 on this side, this is its own loop, so Q0 equals C1 V1, which is going to be 10 times V1, or no, C1 is going to be 12 times V1, which is 10. So it's going to be 120 times 10 to the negative 6. And now what we have is we're going to have the switch thrown to the left. Oh, I can't draw. Okay, so this is going to be C1, C2, C3. And C1 is both a battery and capacitor. So what we write here is Q0 equals C1V plus, well, what we can do really is we can combine this and make it C23. C23V. And we know Q0 is 120 times 10 to the negative 6. And we're going to have C1 and then C23. So I'm going to rewrite this 120 times 10 to the negative 6 equals 120, or C1 is 12. And then C23 is going to be 23 times 2. Because they both equal 23. So it's going to be 46. So it's going to be 12 plus 46V, which is 58. This is going to be 58V. Now we're going to divide both sides by 58. So V equals 120 divided by 58. And they're both times 10 to the negative 6, so it's just going to, those are going to cancel out. I believe those cancel out. So V equals 2.06. Now it's asking what's the charge left on C1. So Q1 equals C1, which is 12, times 10 to the negative 6, but still, times 2.06. Which is going to be 24.8 times 10 to the negative 6. Or maybe not. Is it just 24.8? Yeah, because that's micro. So it's actually just 24.8 microcoulomb. Very nice. I like that problem a lot. Let's do very happy face. This one's kind of crazy. So we have area equals 105 centimeters, which we want to convert to meters. And then are given equal magnitudes. Something that's going to be E. I'm not quite sure if that's E yet, but I'll leave it. And then dielectric material filling the space between the plates 1.1 times 10 to the 6. So the dielectric material, what would that be? Let's see. 1.1 times 10 to the, just 10 to the 6th. Okay. This is going to be V over M. This is going to be C, so this one's going to be Q. And then this one's going to be E, I believe. And then one 0.5 centimeters squared to meters squared is going to be 1.05 times 10 to the negative 2 meters squared. Okay. Now that we know this, it's parallel plate. We have, what are we looking for? We're looking for the dielectric constant K. K equals E0 over E. We need to find E0. E0 equals Q over epsilon 0A. So that's going to be equal to let's see, 9.8 times 10 to the negative 7 over 8.85 times 10 to the negative 12 times A, which is 1.05 times 10 to the negative 2. So, oh my gosh, this constant is a very small number, 1.05 times 10 to the negative 17. That doesn't seem right. No, because it's not. Oh, I have times 10 to the 12. This should be times 10 to the negative 12. That's still ridiculously high. Oh, that's just E0. And we're finding K. Okay. So E0 can be 1.1 times 10 to the 6 divided by this number we just found. We're getting 0.104. No. Something's wrong. E0 over E. Oh. Something's very wrong. Oh. Okay. 9.58. That seems very high. Oh, that's it. And determine the magnitude of the charge. This is going to be Q prime. Q prime equals Q 1 minus 1 over K. Am I right? Yeah. So Q here is going to be 9.8 times 10 to the negative 7. It's going to be 1 minus 1 over 9.58739, which is 8.77 e to the negative 7. Yep. So interesting thing about this problem is it was actually a mistake to have this problem on the homework. It should have been some kind of a dielectric material between a parallel plate, but the teacher, they just saw something between two plates and put it on the homework. What this is just a pure metal. It's just a slab of raw copper. So it's not dielectric at all. So it's very interesting. You act as if the parallel plates are closer by the same difference as the slab makes up when it's inserted, which is such a wild thing to think about. But we should be able to get this done, and it wants it in picofarad. So I would want to get, oh boy, A's in centimeters. B, I mean, areas in centimeters. B and D are in millimeters. And I don't think they give anything else. BDA, okay. Parallel plates. C0 is epsilon 0 A over D. But C, which should be the one with the dielectric material in it, is K epsilon 0 A over D. But K of pure copper is nearing infinity, I believe. So it can't be used. Or maybe it's exactly 1, so it doesn't change anything. It's one of the two. I think my teacher said is infinity. So from here now, what we have and what we can do is C0 equals epsilon 0 A over the distance. C equals epsilon 0 A over D minus B, which is the difference made up here. So I do want to find both of these. So this one's going to be, oh, let's see. Is it 2.35? I actually cannot read that at all. 2.35. So let's first convert this. 2.35 centimeters squared into meters is going to be, oh boy, I shouldn't have wrote those right there. A equals 2.35 times 10 to the negative 4 meters. And if I keep them all how they are, the answer very well might be in picofarad, but I'm not sure. So what we want to find is 8.85. Well, it actually wants it after the slab's inserted, so let's do the other one, the regular C first. 8.85 times 10 to the negative 12th times the area, which is 2.35 times 10 to the negative 4th over, let's see, 2.1 millimeter to meter. 2.1 millimeter to meter. Let's see. B equals 2.1 times 10 to the negative 3rd meter. And D equals 5.1 times 10 to the negative 3rd meter. So now it's going to be D minus B, which is 5.1 times 10 to the negative 3rd minus 2.1 times 10 to the negative 3rd. So I'm getting 6.19 e to the negative 13, and 13 plus 6, because we're going to pico, is, or no, negative 13 plus 6 is negative 7. So it's going to be 6.9325 times 10 to the negative 7, I believe. Pico. Oh, it's pico. Wait. Is it pico? It is pico. Oh my gosh, what the heck's pico? Is it times 10 to the negative 9? If it is, this would be negative 13 plus 9, which is negative 4. I don't know. It's going to be point, let's see, 0.69. Yeah. So it's not even 0.4. It's like negative 1 somehow. To convert to picofarad from farad, it must be times 10 to the negative 12th. Is what pico must be. So now that we have that, now if charge Q is maintained on the plates, what is the ratio of energy stored before and after? So energy stored is is it really Q epsilon 0 A? So what it's going to be is Q epsilon 0 D over Q epsilon 0 D minus B. So this is going to be Q over, let's see, before and after. So before, it's going to be epsilon 0 D divided by Q epsilon 0 D minus B. Now if we do keep, change, flip, the epsilon 0 D minus B, it's going to be Q. What we're going to find is Q's cancel, epsilon 0's cancel. So it's going to be D minus B over D. So it's going to be 5.1 minus 2.1 divided by 5.1, which is 0.588. I really hope that's right. It doesn't look like it's going to be right. Let's do alpha y equals 5.1 times 10 to the negative 4th minus 2.1 times 10 to the negative fourth divided by 5.1 times 10 to the negative fourth. It's the same number, so let's see, Q cancels out, it doesn't matter anyway. Doesn't seem right. Oh, gotta be kidding me. 5.1 minus B minus B over D. Before and after, right? Wait. Oh, they're flipped. It's gonna be 5.1 divided by 5.1 minus 2.1, 1.7. Okay. Okay. Now how much work is done on the slab as it is inserted? Work is, oh boy, change in U, and U is Q squared over 2C. Okay, so here's where we find the original C. The original C is going to be 4.0779 times 10 to the negative 1 picofarad. Work done is the change. The change in, so initial, final minus initial. So it's going to be this minus this, which is 2.85 joule. Does that seem right? Negative 2.85. Oh my gosh. Squared. I was just doing C. Oh my gosh, head in the game. So we're going to have Q. Wait. So this is going to be 3.4 squared over 2 times why did it go on the top? 3.4 squared. And then go to the bottom. It's whatever. I'm just going to do 6.9325. And then we're going to have the same thing, but it's going to be 4.0779. The final minus initial, and the final is going to be the 6.9 minus initial is 1.41. It's going to be 0.58. Doesn't seem right. Final 3 Q squared over 2 times C. C final is 6.9. It's 0.8 minus initial. That's right. 0.583. It isn't the right number. I'm doing it right. Q squared over 2C. final minus initial. Yeah, let's change in. This is C final, C initial, plugged it in, plugged it in. Is it 5.8? Okay, there it is. Sorry. A lot of this is calculator stuff. Oh my gosh. And then lastly, plates on a spherical capacitor. Spherical capacitor. We're gonna have first, I'll do a little radius inner, radius outer. Inner is 37 millimeter. Outer is 47 millimeter, which convert this to meters. I want it in picofarad anyway. Bah, I hate picofarad. This is going to be 3.7 times 10 to the negative 2 meter. This is going to be 4.7 times 10 to the negative 2 meter. And C is going to be equal to 4 pi epsilon 0 AB B minus A. So for this, it's going to be 4 pi times 8.85 times 10 to the negative 12 times AB, which is 3.7 times 4.7, 4.7 minus 3.7. It's a ratio, so it should all be the same. So I'm getting 1.9 to the 9th, 1.93. It's e to the 9th and times 10 to the negative 2. It's a ratio. It's a ratio. Doesn't matter. We're going to pico, which is the negative 12th. E to the 3rd? It doesn't make sense. Yeah, 19.3. Okay. What must the plate area of a parallel capacitor be for the same separation and capacitance? For a separation, it's going to be 47 minus 37, which equals 10 distance. Or we can say that distance equals 47 minus 37, which equals 10. And then capacitance equals 19.3. And for a parallel plate, C equals epsilon 0 A over D. So what we do is I'm going to say CD equals epsilon 0 A. Divide this by epsilon 0. A equals CD over epsilon 0. It'd be 19.3 times 10 over 8.85 times 10 to the negative 12th. Area is going to be equal to 2.1 times 10 to the 13th. It's going to be in centimeters. So let's say this one's in millimeters to centimeters. 2.1 times 10 to the 13th centimeter to meter. Doesn't look like I can do that very easily, so I'm just going to say this one is, let's see, 218. Yep. Okay. I'm going to quickly take a break, and then I will come back for all the lecture problems. All right. We're back. Look how cool that is. It's a cucumber. Go through the examples. Okay. Hold on. Much better. Let's see. Good enough. Find the equivalent capacitance. You want to find okay. C1, 2, 3 plus C1 plus C2 plus C3, which is going to equal 12 plus 5.3 plus 4.5, which is 21.8. Yep. Whoops. Okay. This one's going to be number 1. Number 2. C1, 2, 1, 2, 3 is going to be, let's see, C2, 3. Well, I can see this is 12 plus 1 over 5.3 plus 1 over 4.5 inverse. I'm getting 14.4. Yeah. Okay. Okay. Potential difference applied to the input terminals on the figure below. We have V equals 12.5. we have to find C1. So Q equals C1 V voltage. Voltage should be shared because it's parallel. No, it's all series. It's because it's all series. Current Q is shared. Oh. So let's find C1, 2, 3. This is going to be the C equivalent. Well, actually, we don't know C1, 2, 3. Wait, are we given any of those? I don't want to spoil the problem. Oh. They found C1. We just know voltage. Are we given C equivalent? Okay. Wait, no. We were supposed to be given C1, 2, 3, 4. Wait, right there. Okay. C equivalent is going to be, because they're all series, it's going to be 1 over 12 plus 1 over 5.3 plus 1 over 4.5 inverse. So this is going to be 2.02 UF. Okay. And we find what's the charge on C1. Q equivalent equals C equivalent V, which is going to be so it's going to be this times 12.5, which is 25.29. And we know that the charge on any of these is the same as all of them. So I'm going to say Q1 equals 25.24 because all the Q's are the same. So yeah, they went as far as to say Q equivalent equals Q1 equals 25.24. Okay. Okay. So we need to find V1. Oh, no. C equivalent of the capacitor's charge stored. We need to find Q equivalent. And V1, Q1, V2, Q2. Capacitors 2 and free in Q. So we gotta find everything. We know C1, C6, C3 equals C5, C2 equals C4, and that's all what those equal. Okay. So, let me see. This one's got to be C1. It's got to be C1. Okay. So let's identify what's in series and let's combine them. So this is going to be, oh boy, let's see. There's 2's up there, 1's down here, so. These are in series. There's a junction there, so this must mean it's in parallel. And that must be in, these are definitely in parallel. Now, are these in series or are these in parallel? There's a junction. What does parallel mean? 2 junctions? I guess that's what this problem is going to teach me. So, oh look, C16 is C1 plus C6. Because there is a junction, it would be parallel. We're going to have C16. We're going to have C53. And let's just start with those. One is going to be 3, 6 is going to be 3, so it's going to be 3 plus 3 equals 6. 5, 3 is going to be 4. Be 1 over 4 plus 1 over 4, which is 2. And C53 is going to be parallel to and now what we have here is we're going to have 4, 5, 3, 2. It's going to be parallel. 4 is 2. And then we're going to have C5342 and C16. I won't even try to write anything there. 5342 and C6 this is going to be in series. So then C equivalent of the whole thing is going to be 1 over 6, 1 over 6. which is 3. Yep. So that's part A. Really hope I don't need those. Oh, actually, I do need that. C1. Part A is 3. B, what is the charge stored? So Q equals CV. Q equivalent equals C equivalent. V Q equivalent equals 3 times 20, which is 60. Yep. And now it's asking what's V1 and Q1 of capacitor 1? Oh. Did we even do that? I don't think we did that in class. Wait. We did. Okay. What I want to draw here is essentially what we have. It'd be plus, minus, it'd be 20 volts. What we have here is C 2, 3, 4, 5, 6, and what we have here is C1. Now, what we have to find is C equivalent of 2, 3, 4, 5, 6. So 2 is going to be 2 is 4, so it'd be 2 plus C5, 3 is going to be 4 plus 4 inverse, which is just 2. Let's see, 2, 3, 2, 3, 5, which is parallel with C4. C4 is 2. 2, 4, 6. That's going to be 6. Which is in series. C2, 2, 3, 5, 4 is in series with C6. C6 is 3. This is going to be 1 over 6 plus 1 over 3 inverse. Which is going to be 2. Q equals 2 times 20, and then C1 parallel means voltage comes across. So this is going to be 2, 3, 4, 5, and this one's going to be Q of just 1 is going to be 3. Times 20. The charge on Q1 is going to be 60. Charge on the rest is going to be 40. Mm-hmm. How is it 30? If C16 is 60, the voltage 20 is carried across. Ah, I see. I see my blunder. I guess that there's some kind of invisible line here, which makes sense. This is the plus half, that's the minus half. Yeah, what a great minus sign. And then that these would be in series. Oh. You can't quite do it the way I did it right there. It's good to know. And because they're in series, Q equivalent is C equivalent is 60. Q equals 60. Yeah. And we know it's plus minus. What we're going to have is 60, 20 volts. It's going to be Q1, it's going to be Q2. It's going to make Q for each of these 30. Right? We're going to have 60 equals Q1 times 20. Or it'll be 6. 60. Voltage is 20. Q1 equals 3. And series charge carries over, so yeah. Wait. Carried over voltage. Series. Voltage don't carry over. We need to find voltage. Huh. It's the equivalent of 2, 3. Those ones. This one's gonna be 2. Plus this will be 4. Plus 2. This is gonna be 6. There's V. And then this one's gonna be 6. V equals 10. V equals 10. Now, we know V equals 10 and C equals 3. Q equals 30. So that's how we find Q1. And then from here, finding Q2. Oh my, Q2 is all the way up there. Oh my gosh. This is C1, 6. This is C2, 3, or 2, 3, 5, 4. Okay, I don't really have time for that. Spherical one, we did this one. We did a switch one. I think I knew this switch one. And then, yeah. Let's do the switch, and then let's do the other one. That's going to be all I can do for the night. Okay, so we have 12 volts. C1 equals 4, C2 equals 6, C3 equals 3. And the switch Looks like this drawing that I just drew. So Q0 equals C1 V1, which is 12 times 4, which is 48. Okay, we know that's 48. Now the switch is flipped to the other side. So now what we have is 48 equals C1, which is in parallel with C2 and C3. C2 plus C3 V. And of course, if I wrote C1, I can probably get away with doing that. Now, if I do 4 plus 1 over 6 plus 1 over 3 inverse, I'm getting 6. 48 divided by 6, V equals 8. Now, Q1 equals C1 V1. We call that V1. So capacitor 1 is going to be 4 times 8, which is 32. Yep. And then Q2 equals C2V, which is 6 times 8, 48. Wait. No. Q2, 48. Q2 equals. Ah. Because they're in series, they share a charge. And then C3 is going to be 3 times 8, meaning 24. 48 minus 24 is not 16. 24. No, what they did instead is they did be 48 minus 36. So there, it's going to be equal 16 across C2 and 3, which makes sense, because they're in freaking series, not parallel. Okay. Okay, so area equals 100 centimeters squared. There's going to be like 1 times 10 to the negative 2 meters squared, I'm assuming. And the magnitude, Q equals 8.9 times 10 to the negative 7c. dielectric material. I'm assuming that's going to be E. 1.4 times 10 to the 6 Vm. Now let's calculate K. So E0 equals epsilon 0, no, Q epsilon 0A. Okay, so I've got this, which is a very large number. And then we've got E. We know K equals E over E0. E0 over E. So we're going to have this. We're going to divide that by 1.4 times 10 to the 6th. I'm reading K equals 7.18. This is A. This is B, determine the magnitude. So Q prime, I don't like that, Q prime equals Q 1 minus 1 over K. This is going to be 8.9 times 10 to the negative 7th, 1 minus 1 over 7.1832. And I'm getting 7.66 times 10 to the negative 7. 7.2, that's what I got. And then 7.7 times 10 to the negative 7, yeah. So there it is, all of the homework and all the lecture problems in an hour and 40 minutes. With very minor mistakes, but I think that's more or less fine. So I feel good about this. I have a little card sheet that I will quickly show right here. I'm going to copy this. I'm going to put it on my Discord so that I can copy it later for the test tomorrow. So yeah, peace.